Today we're going to be looking at the homework solutions for yesterday's homework 325. The Washer IQ test is designed so that the mean is 100 and the standard deviation is 15. So, mean, standard deviation for population normal adults. Find the sample size necessary to estimate the mean IQ score of statistics students with 95% confidence. Okay, so here's our formula. It wants us to be within 2 points of the true mean. So this is the mean and standard deviation for normal adults. If we look at statistics students, that's, well, they're also adults. But if we look, it's a more homogeneous group. They're closer together. And typically they should be smarter. So the mean will be greater than 100, and the standard deviation will probably be less than 15. Again, it's more homogeneous group. They're closer to one another. So if we use 15 for sigma, we're good. So first thing you want to do, write down your variables. N, that's what we're looking for. Alpha, well, confidence interval is 95%, 0.05 is the alpha. Don't forget to chop it in half. Sigma, we said 15 right here. I'll split it up here. And our error, it says it wants to be within 2 points. Okay. So if we have alpha is 0.05, we can calculate the critical value for z of alpha over 2, splitting it in half. And if you remember, for alpha is 0.05, the z score is 1.96. So if we look, 1.96, yep, right there. 0.025, chop that 0.05 in half. And on the calculator, you could just do an inverse norm. 0.025, don't forget to cut it in half. Keep those standard, 1.96. So the critical values are negative and positive, 1.96 for an alpha value of 0.05. All right, now we got the numbers, plug them in. Maybe do it this color. So we know N is 1.96 times our sigma divided by 2, and we're going to square that. Now, if I had to guess, these two are really close together. I'm going to say it's about 225. Go to mode 1. 1.96 times 15 over 2, and square that, gives us 216.09. So even though it's 0.9, we still have to round up. Always round up for your n. So 217. Close to 225. There you go. That's it. Done. Next problem. So this one says, the stem plot below lists the ages of applicants who are successful in winning promotion based on blah, blah, blah. Assume the sample is random, simple random, and we want the 95% confidence interval to estimate the mean. Well, let's see, how many numbers do we have? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So we have 5, 10, 15, 25, 29. So n is not greater than 30. So we have to see, is this normally distributed? Well, it doesn't say it is, but we can look. And if it's asking you the problem, it's going to be normally distributed. Let's see, where's our mode? Right here. 45 is our mode. It occurs 4 times. How many numbers are below? 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10, 11, 12, 13, 14, 15. 15 below. and 14 above. So yeah, that's reasonable. That's normally distributed. The mode and the median are right here. I'm pretty sure once we calculate the mean, it's also going to be close to 45. So let's see what we know. We got this data, so if you have a TI, just type it in and be done with it. But we need X bar. So do we know sigma? We do not. That makes this a T interval. So there's our formula for our T interval. So, and remember, it's X bar plus or minus the error to get our confidence interval. So S, we need S. Well, we don't have that either. Both of those you can get from the data though. And I just counted, hopefully I counted correctly, 29. And alpha, we actually do know that one, 0.05. So our T of alpha over 2 are critical values. Well, remember on the Casio, there's no inverse T. And naturally on the TI-83 there isn't either, but we wrote that program. So what you got to do is go to the chart. This is two-tail 0.05, two-tail 0.05. N is 29. That means our degrees of freedom is 28. Remember, degrees of freedom is N minus 1. So 2.048. Okay. Now, if we have a TI and you wrote the program, you can just type it in. But remember, it wants the alpha in one tail, so we got to cut it in half, just like we do for inverse norm. Degrees of freedom is 28. And we get 2.048, same thing. Okay, so now we need this stuff. I'm going to assume you either have a Casio or a TI. I'll do this one both ways, but in the future I'll just use one calculator or the other. Starting with the TI, go to the top, clear, enter to get rid of all that stuff. Type in your numbers, 33, 36, 37, 38, 38, 39, 42, 42, 43, 43, 44, 44, 44, 45, 45, 45, 45, 46, 46, 47, 47, 48, 48, 49, 48. Now, here we go. 49, 49, 51, 51, that's not 51, 52, 54. Hey, I counted correctly, 29 numbers. So get out of there, second mode, go to stat, test, and we decided it was a T interval because we do not know our population standard deviation. That's number 8. We don't have statistics, we have data. So highlight that and hit enter. It's in list 1. If you change it to a different list, you could, type whatever list you need. If you need list 2 for some reason, hit second 2, that'll pop number list 2 right here. Keep frequency as 1 forever in this class. And yeah, 95% confidence is what we need. And there's our interval. It gives us X bar, it gives us S, and it gives us our interval. So I'll just screenshot that. Hello, Alana. So I'm going to stick that over here. So we got our interval right there, done. However, let's assume you don't have the TI. Let's assume you're using the Casio. Here's how you do it on the Casio. I'll move this over so I can write down my X bar and standard deviation. We're going to go to mode number 3, stats, one variable. And you can type all those numbers in. That's why I'm only doing this once. On the future ones, I'm probably just going to use a TI. It's much more annoying to type in. Okay, good. We have 29 numbers on this one as well. So assuming I didn't mess up on all three counts, then we're good to go. Whenever you have those typed in, hit AC, Shift 1, and want some variables. We need X bar, 44.5. Hey, it's the same as this one. Type in the same numbers now. Our data goes to one decimal place. Our data goes to one place, no decimal place, it's one place. So our X bar needs to go to one decimal place, 44.5. Our standard deviation, let's get that. Shift 1 for S. Always use the SX for here. Don't use the sigma. That's going to mess you up. And it's 5.025, same thing as we have here. Again, one decimal place, we're going to round it to 5.0. Now, I showed you how to store numbers. Let's see if it works here. Yeah, okay, let me do this. So this is going to be helpful. So if I come back here, mode 1, I have A stored as my standard deviation, and B is my mean. So now we can use those numbers later on, and they type S right here. And I'm about to use it in this error formula. So if you don't remember how to store a number, I just went through it. You have your answer. After you get your answer, you shift this button right here, about 7, STO stands for store. Then you hit directly whichever letter you want to store it as. Let's say F, because why not? And then you hit equals. Clear it out. And now alpha F is that fraction. Boom. Our T critical value is 2.048. Our S, I'm going to put 5.0 here, but in the calculator, I'm going to use all those decimal places I can. That's why I stored it, because we don't like rounding until the very end. And N, we counted with 29. And again, if it's asking you to do the problem and it doesn't specifically state that it's normally distributed and you can see the data, you can pretty much tell if it's normally distributed. If not, assume it is, because it doesn't say, if you can't do this problem, tell me why, then you can do the problem. So 2.048 times, I believe I called that A, divided by, or over, square root of 29. That's my error. So I'm going to store that to E for error. So 1.911. And if you don't have a calculator that you can store on, just go a few extra decimal places until the very end. At the very end, we're going to round to one decimal place to go at least 3 out for all your intermediate answers, and you should be pretty much the same. Should be pretty okay. Now I have X bar as B, I believe. Let's check. Yep, there it is, B. So I'm going to do B minus my error. That's my lower bound, 42.6. And for my upper bound, I'm going to change that to a plus, 46.4. So your formula, don't forget, copy it. It's just X bar plus or minus your error. That's all we did right here. And let's compare the intervals, 42.6, 42.6, 46.4, 46.4. We're good. Let's see what the actual numbers were. We got 46.4285, so I would round the same thing. So yeah, good to go. Let's look at the next problem. All right, the world's smallest mammal is the bumblebee bat, also known as the whatever. Such bats are roughly the size of a large bumblebee. Listed below are the weights in grams from a sample of those bats. Assuming that the weights of all such bats have a standard deviation, that says all such bats, of 0.3 grams, construct a 95% confidence interval to estimate their mean. And then, after we do that, we're going to compare it to this 1.8 here. So, since we know the standard deviation of all those kitty hog bats, it's a Z interval. There's the formula. So, again, we're going to type in all these numbers. If you want to see how to do it on the Casio, go back to the previous problem because I'm just doing this on the TI. I'll do it by hand, but the typing in the numbers part, yep, TI only. Clear the list and type them in. And make sure you watch those spaces. 1.7.6. I guess I hit enter. 1.7. 1.6. 1.5. 2. Oh my goodness. 2.3. 1.6. 1.6. 1.8. 1.5. 1.7. 2.2, 1.4, 1.6, 1.6, 1.6. Let's see, that's 15 of them. 1, 2, 3, 4, 5, 6, 8, 9, 10, 11, 12, 13, 14, 15. I always like to count and make sure I have the right number of numbers. That way it's less likely that I messed up. Check our conditions. Does it say it's norm distributed? It does not. And n is less than 30. So really what we should do is check and see if this data is normally distributed. Hey, guess what, the TI can do that. Let's see, plot on. I'm going to zoom to stats. It's really not that normally distributed. But we can assume that the population is, I guess. Again, if the problem asks you to construct a confidence interval, it doesn't say, can you construct the confidence interval? You can. So these weights are normally distributed for the population, I guess. Not so much for the sample. So it's normally distributed, it should be like a bell shape. Anyway, we're going to continue working and assuming that it's normally distributed. If a question asks you what are the conditions, or whether or not you can do it, then you'll have to make sure it says normally distributed somewhere. Hint for the test. Well, quiz tomorrow. Anyway, back to the problem. So I got my stats in there. I'm going to run a T interval or a Z interval. Which one? We know sigma, so we're going to run a Z interval, number 7. Again, we have the data. Standard deviation you have to put in there is 0.3. This is L1 for me. Put whatever you need in there. I suggest just keeping it in L1. Frequency is always going to be 1. And we want 95% confidence. And we're done. Okay. All right, so I'm going to write this information down so I can do it by hand. X bar is 1.7, and I'll get the exact answer on here in a minute. S is 0.258, so 0.3. Oh, sorry. Our data goes to 1 decimal place, we need to go to 2 decimal places. 71 and 26. Sigma is given as 0.3. Alpha is 0.05. So Z of alpha over 2, done this one too many times, is 1.96. And N is 15. So real quick, let me just store X bar and S in my calculator. You do this too if you're on the Casio. Remember, shift so, get your important numbers on there. Actually, we don't need S, do we? If we look at our formula, it has absolutely nothing to do with S. If we're doing a T distribution, we need S, but since we know sigma, that's what we're using. So I'm just going to take X bar, and I'm going to store that to A. Actually, you know what? I like storing it to X on the TI because I don't have to push the alpha button. So there we go. Now I'm not worrying about rounding. And then we're going to type in our calculator this formula here. 1.96. That's my critical Z value. Times 0.3 divided by square root. 15. Again, usually I like to put my numerator and denominator in parentheses. It won't hurt on this one because we're not adding or subtracting anything, and we only have one product in the denominator. Oops, that's not what I wanted. So boom, there we go. That's my error. I'll store that to E. 0.1518. I've got the whole thing stored. If you're doing this by hand, I'd suggest you stick that 2 on there as well. If you're not storing the data in the calculator, because we have 2 decimal places here, go 3 extras, you shouldn't have to worry about any kind of rounding issues. All right, so I need to do X minus E. That's x bar minus my error is 1.56. And if I do x plus e, I get 1.87. And there's our confidence interval. Let me redo it on here so we can compare the results. That should be the same. Oh, there we go. 1.56, 1.87. Boom, same, done. Now, if we read the second part of the question, use the confidence interval to determine whether this sample of bats is from the same population with a known mean of 1.8 grams. Seems reasonable. I mean, it's the population mean is inside of our confidence interval, so I'd say it seems reasonable. All right. Okay. Next question. All right, we're looking for N again. They want to estimate the average amount of time that full-time college students spend watching TV each day of the week. Find the sample size necessary to estimate the mean with a 15-minute margin of error. So we're looking for this in minutes with a 96% confidence interval this time. Also assume that the pilots show the standard deviation to be that. Okay. So it's a good thing this was we know this is the standard deviation here, because, yeah, I don't think we can get the 96% confidence if we're looking at a T-chart. No, that's not an option. That's 0.04 would need be what we need over here. That ain't happening. But we estimate the sample size with a Z test anyway. So we're always using Z down here, never the T. Let's see, we got our standard deviation, we've got our error, and we've got our confidence level. Write them down. And what we're looking for, alpha is 0.04, don't forget to cut it in half. Z of alpha over 2, why not? We need to figure out what that is. Sigma is 112.2, and error is 15. So let's use our chart. If Z is, if alpha is 0.02, right here, oh no, it's 0.02, we need 0.02. 0.02. Somebody's upset. Take your shoes off. So this one's 2,000. So this one's 2 10,000. This is 3 10,000. This one's close, so we're going to use negative 2.05. That's sure she doesn't want, but she doesn't want something. And, sorry, we're always going to use positive here. Let's check that with an inverse norm. .05, okay. And TIU2 help you know how to use the inverse norm. Alright, if we look here, we got all the info we need now, plug it in. Don't forget we're squaring all this. And square it. So yeah, type it in. I'll type it into TI since it doesn't have math type. So clear your screen. Make sure you put your numerator in parentheses and the whole dang thing in parentheses because you're the whole dang thing. Numerators in parentheses. Denominators in parentheses. Close the parentheses of the whole dang thing and square it. 235.1. So we need 235 people, right? Wrong. We need 236. Always need an overestimate for n. Always round up unless you get an integer, then you can actually use the integer. So go grab 236 full-time college students randomly, and then you'll have a good estimate of the average time to watch TV. Okie dokie then. What's next? Right here. Shoveling snow. So you can read this if you want. First one says find a 95% confidence interval to estimate the population mean for those who shovel snow manually. So A is manually. Okay. So to read all this, it says it's an important 10 subjects cleared tracks of snow using both methods and their maximum heart rates were recorded. Yada yada yada. I don't see sigma anywhere. I don't see sigma. I do see S. Since we don't have sigma, we're going to use a T interval here. So we got our data up here in X bar and S. And for A, we're doing it for these manual people. And it's 10. X bar is 175. S is 15. Alpha is 0.05. Our critical value is not 1.96 because it's a T. Go look it up. N is 10, degrees of freedom is 9, 0.05 and 2 tails. 9, so we're going to use this right here. 2 tails is 0.05, 2.26. Yeah, 2.262. Got what we need, plug and chug. And now she comes. So error is going to equal 2.262 times 15 over square root of 10. So again, if you're using a TI, all you need to do is just type this in. The T interval would be done. 2. Oops, go to mode 1. 2.262 1262 times 15 over square root of 10. That gives me my error. I'm going to store that to E for error. And to get my confidence interval, I'm going to do my X bar, 175, plus E. Well, minus first. $164.3. Yeah, they're going to the 1st place. So confidence interval needs to go to the 10th place. 1.643, 164.3, sorry. And then we change that minus to a plus. We get 185.7. Okay. TI users, we go to test number 7. We got stats. That's 15. 175 and 10. Again with a 95% confidence. Oh, and what did I just do? I clicked T when I went to click, I clicked Z when I went to click T. Allow them to pick it up. Very good. Put it back where it goes. And we get a T interval of 164.3 and 185.7. Good, they match. Let's see. How was I going to do it here? I was going to do it on 2 pages. I think I can do it both right here. So for B, we're looking at the electric sensor. You need to go put you night. N is again 10. X bar this time is 124. And S, our standard deviation of the sample, is 18. Alpha value and T value, they stay the same. So I'm not even about writing it. Error is also going to be, the only thing we're going to change is it's 15 right here, and you see an 18. So 2.262 times 18 over 10 this time. 18 over square root of 10, sorry. And that is where I'm going to store my error. Okay. Check. Yep. X bar is 124 minus my error gives me 111.12. And we're just going to go to 1 decimal place again because, well, actually, we can go to the whole place because our data gives us X bars 1 decimal place. So we're actually going to round these to 1 decimal place. They're probably in that basket. $136.9. Again, we're going to go to 1 decimal place. We're going to go to 1 place. So that's going to be 111. It's going to be 137. Over here, that's going to change these. This is going to be 164. This is going to be 186. Since that was a 7, whether or not it went up. Oops, what was it? Since that was a 7 right here, there was at least a 6 beforehand, so that's still going to make it go up either way. But not a 7. 6. 186. All right, if we do the T interval on the TI, $124, $18, everything else is the same. $111 to $137. So if we compare our confidence intervals, I'll put E here, this is a confidence interval. We found E to be 12.9. So if we compare these two confidence intervals, we can see that using the electric blower is definitely a lot easier on your heart than the manual shoveling. So if you got heart problems, go get an electric shoveler or move to Louisiana where there is no such thing as snow. And I was going to do it on 2 separate pages. We didn't need that. We're doing it here. Last one, and again, my apologies on this one. This says S right here, but that should actually be a sigma. Whenever I copy pasted it from the PDF into Word, it translated the Greek to English, and I didn't notice. When people smoke, the nicotine they absorb is converted into cotinine, which can be measured. A sample of 40 smokers has a mean cotinine level of 172.5. Assuming that sigma is known to be 119.5, find the 90% confidence interval estimate of the mean cotinine level of all smokers. So we've got sigma is 119.5, and X bar is 172.5, and it's 40. Alpha right there is going to be 10. So sigma is known. We're going to use the Z interval. N is greater than 40, so we're good to go on that piece. Yeah, how's full smoke? How it's cooking. So yeah, write down your variables, and it's 40. X bar is 172.5. Sigma is given to be 119.5. Alpha is 0.1. So I don't remember that Z-score. I have to go look it up. But I'm not going to look up 0.1. I'm going to chop it in half and look up 0.05. You can use the chart. I'm going to use a calculator. .65. Actually, if you look up on the chart, it'll say 1.645. Yep. So the 95% confidence interval. Well, for alpha is 0.05, we have 1.645. There we go. We'll use that. If you round it to stress places, that's fine. Again, at the end, I'll give a little interval of answers that are acceptable. So now we just need to find the confidence interval. TIs, you're done already. This time we are doing it D interval with statistics. We know sigma is 119.5. 172.5 for X bar, N is 40. Confidence interval of 0.90. Calculate that. 141.4 to 203.6. So that's what we need for our interval. So look at X bar, so minus our error. So we can find our error. Excuse me. I'll find it on here since if you're doing it by hand, you're probably using this calculator anyway. We're going to do 1.645 times 119.5 over square root of 40. 31 point blah, blah, blah. Store that to E or whatever you want. Doesn't really matter what you name it. And 31.08. Keep on going if you have some other calculation you're not storing it with. 172.5 minus our error, 141.4. They give us X bar to the 10th place, so we're rounding the 10th place. Plus there, 203.6. Compare that, 141.4, 203.6, same thing, and we're done, people. Quiz will be tomorrow. Make sure you know how to do all these problems. Make sure you know the difference between a Z and a T. Make sure you know the conditions for being able to actually do these problems. If it doesn't say it's more distributed on the quiz, and it does ask you to make sure you can do it, check it. Make sure n is greater than 30. If n is not greater than 30 and it's not normally distributed, you can't do it. All right, that's it for today.